Here we will show how to do a power spectrum measurement of a device under test. That means power basically as a function of time. And the system has been calibrated before. And the next step that we need to do is typically for a power spectrum measurement of for a radiating device, the reverb chamber has stirrers inside. And the stirrer mode that we typically select for power spectrum measurements is the stepped mode. So there are two modes, step mode and continuous mode. Step mode means that the stirrers will be put to a certain position and a measurement will be done. Then a next position will be taken and a measurement will be done. And then, in fact, you're stirring the fields in the chamber. And at the end of the day, when you collect all that information for the different stirring positions, applying some averaging to that, you in fact get a field, an average field that is pretty uniform across the chamber. And that makes the measurement very independent of the position where you are putting the device under test. So here I will go into stepped. I'm going to use the default settings. And there you can see that for the positions, there are 10 positions for the horizontal stir, which is positioned at the top here. And then in the back, there is a vertical stir that also has 10 positions. And we are doing, in fact, steps of 5 degrees each time. And then for each setting, in fact, the spectrum analyzer is going to measure the power spectrum and then all the data collected. And there is some averaging applied at that moment. Now, the spectrum analyzer here, we're not doing anything specifically on the spectrum analyzer. Just the default settings are being used, driven by the software in the reverb chamber. Now, of course, we must make sure that we define the span across which one we are going to measure. That span needs to be a subset of the span that for which we calibrated, because otherwise we will mix some certain measurements that's not calibrated and calibrated. So we need to make sure we are within that span. And here I'm going to select 62. So we have a radiating phased array antenna at the moment configured in the system. And it's radiating around 62.6 gigahertz. So I'm going to take a span here from 62.3 gigahertz to 62.9 gigahertz. So we have a 600 megahertz span that we're taking at this moment. And then I'm actually going to measure. And on the screen, you see the noise floor, and you see one spike moving up and down. So we are radiating at one frequency. And the nice thing of this approach is that very quickly, suppose you have LO leakage, suppose you have spuriouses, they also will show up within the span for which you were collecting the measurements. So it allows you to very quickly get insight in the behavior or in the abnormalities of the device within one power measurement, basically. And just imagine that you need to do that in an anechoic chamber. And here you do have the result. So you can see, in fact, that this is a nice device. We see the noise floor. And then here we have one nice spike at the frequency at which it is radiating. So this is the total radiated power provided by the device at that frequency. So this gives you a quick overview of how you can do a power spectrum measurement as a function of frequency.